What happens when the thing being governed no longer stays still? Systems continuously evolve, models learn, and agents execute. Traditional governance models struggle to keep pace with this continuous change. For the last 3 decades, enterprise operations relied on a simple assumption: systems changed slowly. Code was written, validated, and deployed in discrete cycles, meaning oversight could safely operate in retrospect. The AI era breaks that assumption. Today, machine learning models continuously ingest new data. AI agents make autonomous decisions, and enterprise workflows self-optimize in real time. The code does not stay still. This creates a severe structural vulnerability for regulated organizations. A dangerous asymmetry has opened up between the microsecond speed of AI execution and the scheduled periodic frequency of compliance governance. As execution becomes continuous, governance must become continuous. Real-time monitoring tracks what is happening. Runtime governance proves why it is happening, verifying decisions at the exact moment they occur. Closing the gap between continuous execution and periodic governance is an existential architectural requirement for deploying AI in the enterprise safely. To see why legacy frameworks fail under continuous change, we have to look at the baseline standard of the Computer System Validation, or CSV, era. This linear flowchart illustrates the CSV model. It forces a rigid sequence: validate, deploy, operate, and eventually audit. This model assumes the system remains exactly as it was the day it passed validation. The environment is treated as permanently set. Because of that assumed stability, the audit happens as a completely separated retrospective event. It is disconnected from daily operations, relying on static documentation generated months prior. As software development accelerated, the industry attempted to adapt by moving to Computer Software Assurance, or CSA. This revised loop represents the CSA lifecycle. It updates the sequence to focus heavily on risk-based testing prior to deployment. Yet a structural flaw remains intact. The framework still relies on discrete intervals for review. It checks the system's compliance on a scheduled calendar date, rather than evaluating the system's actual behavior in motion. Accelerating a periodic audit schedule does not create continuous assurance. It merely shortens the duration of the operational blind spots between reviews. Execution is becoming continuous, while governance remains largely periodic. A gap is emerging between these speeds, and that gap creates risk. Agentic AI workflows do not pause to wait for scheduled review cycles or human permission to execute decisions. They operate continuously. The regulatory response to this is already visible. The FDA is actively shifting toward real-time clinical trials, establishing a leading signal for all governed industries. This side-by-side comparison shows the shift. On the left is the legacy pipeline, heavily bottlenecked by discrete phases of data gathering, analysis, and manual submission. On the right is the emerging model. The trial feeds directly into a continuous data stream, enabling continuous monitoring, visibility, and dynamic decision-making. In this continuous flow, collecting data is no longer the primary operational challenge. Systems generate massive volumes of data automatically. The critical hurdles for regulated enterprise are now proving provenance, tracing the lineage of AI-generated actions, and maintaining continuous explainability over autonomous decisions. If the ultimate regulatory authority demands dynamic, real-time evidence to approve a trial, enterprise software architecture must permanently abandon retrospective audits to remain viable. Governance is not the restriction of execution, it is the ability to reliably reconstruct, verify, and trust the exact path of a decision. To achieve that, the legacy sequence of executing work and reviewing it later is discarded. It is replaced by the continuous govern-OS sequence: signal, state, action, and evidence. It begins with the signal, the initial environmental observation or data input the system receives. Next is the state. This captures the specific operational context, the risk evaluation, and the exact system status at that specific microsecond. Then the action occurs. This combines the AI's autonomous decision with the actual execution of the task. Finally, the evidence. This is verifiable proof, generated automatically in tandem with the action itself. By structurally binding the creation of evidence directly to the moment of action, the system natively provides verifiable proof across time. Separate retroactive audits become obsolete. The market is currently focused heavily on AI-native operational orchestration, building AI chief of staffs and autonomous business agents to handle complex tasks. These platforms successfully orchestrate work, but they fail to generate verifiable trust. They execute, but they do not assure. This three-tier stack maps the modern enterprise architecture. At the base is the foundational infrastructure layer: data, core systems, cloud environments, and compute. Above that sits the execution layer. This is where operational tools, AI agents, language models, and humans actually perform the work. Work flows rapidly within this middle tier, but without independent oversight structurally enforcing rules, this execution layer operates as an unregulatable black box. GovernOS caps the stack. It provides a distinct upper layer entirely dedicated to trust, housing governance, policy, risk, authority, and assurance. This trust layer actively dictates policy downwards, setting boundaries for the execution layer, while simultaneously pulling verifiable evidence back upwards from every action taken. An AI agentic system operating without a dedicated trust layer to provide provenance is not a deployment solution. It is an enterprise liability. Regulated organizations cannot transition from periodic manual audits to full runtime governance overnight. It requires a structured adoption path. This timeline maps the transition. It starts by moving away from static records in Phase 1, governance documentation, to standardizing routine tasks in Phase 2, governance automation. Next, we embed compliance directly into operational code. Phase 3 establishes governance enforcement, leading to Phase 4's governance infrastructure. The path resolves at Phase 5, runtime governance, where oversight operates invisibly alongside execution. This is runtime governance. The oversight mechanism is structurally embedded into the execution flow, operating exactly as fast as the system it protects. The future of the enterprise requires governance frameworks to match the velocity of AI execution. GovernOS provides the architectural substrate to bridge that gap, enabling trusted, continuously assured execution across all human and AI workflows.